Derive the following using rule CP. So what is rule CP? Actually, this is called an argument, a sequence of premises. If I name this as H1, if second, if I name this as H2, third, if I name this as H3, fourth one, if I name this, I'm naming this as C. If I write all these statements as something like this H1, H2, H3, comma C, this sequence is called an argument, right? So that means testing the validity of this argument is nothing but showing that H1 and H2 and H3 implies C, right? Now this is an argument. Now, we want to test the validity of this argument. Now P conditional S. Why I am using P, rule CP, right? If the conclusion of an argument involves conditional statement P conditional S, then we should consider hypothesis of that conditional statement as additional hypothesis of that conditional statement as additional premise, and we should show that the conclusion part of that conclusion. That means after arrow there is a symbol S. We should arrive at the after assuming that the symbol to the left of arrow, that is P, after taking this P as additional premise under all these premises, we want to show that S is the consequence. Then by rule CP, P conditional S follows. So this is the basic idea. Let us start our proof through formal proof technique. So this is formal proof technique, right? Step one. Okay. So let us start our first step with this statement P. Okay, rule P, because this is a premise and this is nothing but additional premise. Should write here additional premise. If it is premise, it should be should write the step number as logical consequence step one. So this step is nothing but logical consequence of itself, right? Now step number two. Now have a look at the premises. Because I have started with the premise P. Okay, observe the premise involving this P. Yes, negation PRQ. This involves P. That is why I'm using negation PRQ. This premise. So instead of writing, I'm using the given premise from as hypothesis. We simply write rule P. Right now, if it is rule P, it should be two. Right, that means step number two is the logical consequence of itself, because this is rule P. Next step number three, as we all know that rule T, uh, we all know that there is a rule. So that rule is when negation PRQ is true and P is also true, that implies Q is true, right? Is it clear? So this is known as a disjunctive syllogism, right? Is it clear? Yes, disjunctive syllogism. So that is why you should write Q, right? So disjunctive syllogism on the steps one, disjunctive syllogism on the steps one and two. So because step number three is a logical consequence of steps one and two. To the left of bracket one, this is set one. To the left of bracket two, this is set two. The union is set of 1 comma 2. That means step number 3 is the logical consequence of the steps 1 and 2. Now we arrive at the step 3. We ended with the step 3 with the symbol Q. Q is true. Now look for the premise which involves this Q. So we have this statement negation Q or R. Negation Q or R. Okay, because this is a given premise, I'm using given premise. So instead of writing that, given this is given premise, we should specify this as rule P. If it is rule P, it should be in braces 4. So fourth step is the logical consequence of itself because this is hypothesis. Next, step number 5, right? So rule T. That rule is rule T on steps 3 and 4. So that rule is disjunctive syllogism. Okay, so the disjunctive syllogism means when negation Q or R is true, when Q is true, negation Q R is true means that implies what? R must be true. So this is the valid conclusion drawn from these two, and this is known as disjunctive syllogism, right? So fifth step is the logical consequence of the steps. So 3 and 4 to the left of bracket 3, the set is set of 1 comma 2, and to the left of bracket 4, this is set 4. That means fifth step is the logical consequence of the steps 1, 2, 4. If any mistake committed by me at the steps 1, 2, 4, it will be carried here also. That is why I'm okay listing out this sets, listing out the logical consequence of to the left of these brackets. Now, because I have used mm, premise negation PRQ, negation QR also over. Next, I have R conditional S in hand because okay, now R is in hand. R is true. I have a statement R conditional S. This is also true. Actually, this is a given premise. Rule P means this is given premise. If it is rule P, it should be 6. Now R is true and R conditional S is also true means what will happen? Rule T. So that is by the by modus ponens. By modus ponens. This is a Latin word. By modus ponens on step number 5 and 6. According to that modus ponens, when R conditional S is true and R is true, okay, then S will be true. So it follows. And step number 7 is the logical consequence of the steps 5 and 6 to the left of bracket 5. Okay, 1, 2, 4 are there. To the left of bracket 6, there is a set 6. So the union of these two sets is nothing but this. So this set indicates what? Bracket 7 is is the logical consequence of the steps 1, 2, 4, 6. Right? Now, see, I have started with an additional premise P, right? After using all these premises, I arrived at the conclusion yes, right? So that means by rule CP, step number 8 is nothing but what? By rule CP. So this is rule CP. By rule CP, P conditional as follows. By rule CP, P conditional, because I have assumed, have started with my discussion with an additional premise P, by assuming that P as additional premise, right? After using all these premises, I got S as conclusion means P conditional S. The conclusion P conditional S follows from the rule CP on uh, the steps 1 and 7. Of course, eighth step is the logical consequence of the steps 1 and 7 means eighth step. So to the left of bracket 1 it is 1 and to the left of bracket 7 the set is 1, 2, 4, 6. That means last step is the logical consequence of the steps 1, 2, 4, 6. So that means this is our conclusion. This is the conclusion. This is the conclusion. Therefore, uh, P conditional yes is the valid conclusion drawn from the given premises given premises okay given premises. Therefore, hence the result. That means from this the result follows. Thank you.